You know, there is a number that keeps physicists up at night. It is a very big number. If you look at the universe, really look at it, and you try to count all the stuff that makes up the matter, we can see the stars, the galaxies, the nebulas, the dirt in your backyard, the skin on your hand. If you count every single electron in the observable universe, you end up with a number somewhere around 10 to the power of 80. That is a 1 followed by 80 zeros. It is a number so colossal that our brains cannot even begin to imagine it. It is just a blur. But what if I told you that we have been counting wrong? What if I told you that the real number isn't 10 to the 80? What if I told you that the total number of electrons in the entire universe from the Big Bang until the end of time is actually just 1? Yes, 1. Just one single electron doing all the work, dancing everywhere at once, weaving the entire fabric of reality by itself. It sounds crazy. I know it sounds like something a mystic would say after staring at a wall for too long. But this isn't mysticism. This is physics, and it is an idea that leads us to one of the most profound, beautiful, and absolutely absurd secrets about how time and matter really work. If you stick with me, we are going to take this idea apart, piece by piece, and see if we can put the universe back together in a way that makes sense, because nature is strange. But she is never ever boring. You see, the problem with the way we are taught science in school, so that we are taught to look at the world as a collection of things, little billiard balls bouncing round. We think of an electron like a tiny little marble carrying a charge whizzing round an atom like a planet round the sun. And that picture is fine if you want to pass a chemistry test in high school. But if you want to understand how the world actually works, that picture is a disaster. It is worse than wrong. It is boring. Because if you really look at these particles, you notice something very suspicious. Something that should bother you. Take 2 marbles. You make them in a factory. They look the same. But if you look really close with a microscope, one has a scratch here. The other has a bump there. One is slightly heavier. One is slightly lighter. They are distinguishable. You can tell them apart. Now, look at electrons. You take an electron from an apple in your fridge. You take another electron from a star at the edge of the galaxy. You bring them together and you measure them. They have exactly the same mass, exactly the same charge, exactly the same spin. There is absolutely no way to tell them apart. They are not just twins. They are identical in a way that nothing in our everyday world is identical. Why? Why should the universe be so monotonous? Why isn't there a fat electron and a skinny electron? Why isn't there a blue one and a red one? Why is every single one of them a perfect copy of every other one? It is almost as if they were all made from the same mold. Or perhaps they are not copies at all. Before we get to the answer, which involves time travel and antimatter, yes, really, I want to ask you a favor. We are trying to do something different here. We are trying to explain the world without hiding behind fancy words or mathematics that no one understands. We want to find things out. If you enjoy this kind of exploration, if you want to join us in decoding the universe and seeing the world as it truly is, please hit that subscribe button. Let's find things out together. Now, let's go back to a phone call I received a long time ago. I was a graduate student at Princeton. I was young, enthusiastic, and I thought I knew a thing or two. And then I got a call from my professor, John Wheeler *. Now, Wheeler was a giant of a man intellectually. He had this way of looking at a problem and turning it completely upside down. He calls me up and says, "Feynman, I know why all electrons have the same charge and the same mass." And I said, "Why?" He said, "Because they are all the same electron." I thought he was joking, but he wasn't. and as he started to explain it to me, I realized he had found a way to visualize the history of the universe that completely shatters our intuition about time. To understand what Willow was saying, we have to stop thinking about time the way we usually do. We usually think of time like a river flowing from the past into the future, carrying us along with it. We think now is special, but in physics, especially when you start drawing space-time diagrams, time is just another direction. It is like space. Imagine you have a piece of paper. The horizontal direction is space left and right. The vertical direction is time up as the future, down as the past. Now imagine an electron sitting still. It is not moving in space, but it is moving in time. It is getting older. So, on our piece of paper, its path is a straight vertical line. Going up, we call this a world line. If the electron moves to the right, the line slants to the right. If it moves to the left, the line slants to the left. Simple, right? A world line is just a record of where the particle has been and where it is going. But Wheeler said, what if this line doesn't just go up? Imagine you have a long piece of string, a very, very long piece of string. This string represents the history of that one electron. Now, instead of stretching this string straight up from the past to the future, imagine I crumple it up. I make a giant tangled knot. I weave it back and forth. I make loops. The string itself is continuous. It never breaks. It is just one long path. Now, here is the magic trick. This is where you have to use your imagination. Imagine that now. The present moment is a horizontal slice through this tangled mess, like we are slicing a sausage or slicing through a great big tapestry. If I pass a slice through that tangled ball of string, what do I see? I don't see one string. I see lots of little dots. I see a dot everywhere the string cuts through my slice. Some of those parts of the string are going up towards the future. Those are the electrons we see, but because the string is looped back, some of those parts of the string must be going down towards the past. What does a particle look like if it is moving backwards in time? This is where it gets really interesting. This is where we have to talk about something that sounds like science fiction, antimatter. You see, when we look at the equations, the laws that govern how electricity and magnetism work, they are surprisingly symmetrical. They don't really care which way the clock is running. If you take a movie of an electron moving and interacting, and you run that movie backwards, the physics still makes sense. But there is a catch. If you reverse the time in the equations, it looks exactly the same as if you reverse the charge of the particle. So an electron moving backwards in time doesn't look like an electron moving backwards. It looks like a particle with the same mass as an electron, but with a positive charge instead of a negative one moving forwards in time. We have a name for that particle. We call it a positron. It is the antimatter twin of the electron. So when Wheeler told me they're all the same electron, here is what he meant. The universe is this giant space-time block. Inside this block, there is this tremendous tangled world line. It goes forward in time, and we see an electron. Then it turns round and goes backward in time, and we see a positron. Then it turns round again and goes forward, and we see another electron. Then it loops back again, back and forth, zigzagging through the centuries, knitting the fabric of the cosmos. If you take a slice through this knot at the year 2024, you intersect the same line billions and billions of times. Half of those intersections are the line going up and the other half of the line going down. But to us, trapped in the present moment, we don't see the connections. We just see billions of separate electrons and billions of separate positrons. We think they are all different particles because we can't see the turns. We can't see the loops where the electron reverses its direction in time to become a positron and then reverses again to become an electron. It is like looking at a bombardier trying to drop a payload on a road at night. He sees the road and flashes. He sees a piece here, a piece there. He might think they are different roads, but if he could see the whole landscape at once, he would see it as one continuous highway winding through the hills. When Wheeler put this idea in my head, I immediately saw the flaw. I was skeptical. I said, "But Professor, there aren't as many positrons as electrons. If this theory were true, if it is just one string going back and forth, then for every line going up an electron, there has to be a line coming down a positron. The number should be equal. But look round. The universe is made of matter. Electrons are everywhere. Positrons are rare. We only find them in high-energy experiments or cosmic rays. Where are all the positrons?" Wheeler had an answer ready. He said maybe they are hidden in the protons or maybe the neutrons. Now, that particular part of the idea didn't turn out to be right. We know now that protons and neutrons are complex things made of quarks, not just hidden positrons. The symmetry isn't perfect in the way Wheeler guessed in that moment, but the core idea, the idea that a positron is just an electron moving backward in time, that stuck. That became a cornerstone of how we do quantum electrodynamics, QED. When we draw Feynman diagrams, those little pictures are used to calculate how light and matter interact. We actually draw positrons as arrows pointing backward in time. It is not just a bookkeeping trick. It is a fundamental insight into the geometry of reality. Think about what happens when an electron meets a positron. They annihilate. They release energy in the form of photons, light. They vanish. But look at it from the point of view of the one-electron theory. The electron is moving forward in time. The positron is the same electron moving backward in time. When they meet, it is actually just the point where the particle decided to do a U-turn. It reached a certain point in time and turned around to go back. So annihilation isn't the destruction of matter. It is just the particle turning a corner in time. The creation of a pair. An electron and a positron appearing out of nowhere is just a particle turning round again to go forward. It is fundamentally a geometric view of the universe. It treats time as space. It treats history as a map that is already drawn. Now, I want you to pause for a second and let that sink in. This means that the electron in the tip of your finger right now could be the exact same electron that was in the brain of Albert Einstein. It could be the same electron that powered the first lightning bolt on Earth. It could be the same electron that is currently burning in the heart of a star, a billion light years away. It takes a journey. It lives through the life of a dinosaur. Then maybe it turns round, goes back to the Big Bang, turns round again, and becomes part of an iPhone screen. It means that the distinction between this electron and that electron is an illusion created by our limited perspective. We are slicing the sausage and thinking every slice is a separate object, but it is all one meat. It is all one string. Why does this matter? Why should you care about a theory that sounds this absurd? Because it challenges the most stubborn illusion we have, the illusion of separation. We look at the world and we see me and you. We see here and there. We see now and then. We build our whole lives round these separations. We think that objects are distinct, independent actors on a stage. But quantum mechanics, and specifically this view of quantum electrodynamics, tells us that at the deepest level identity is blurry. The fact that you cannot distinguish one electron from another is a hint. It is nature whispering to us that the manyness of the world might be a surface phenomenon. Underneath there is a unity that is harder to see but much more profound. Now I have to be honest with you. That is the only way to do science. You have to be honest. Is this theory that there is literally only one physical electron accepted as the absolute truth in physics today? No. There are problems with it, as I mentioned. The missing positrons are a big issue, and with the discovery of more particles, the picture gets more complicated. We don't literally believe there is only one string. However, the mathematical tool that came out of it, the idea that antimatter is matter moving backward in time, is absolutely correct. It is the only way we can make the equations work. It is the only way we can calculate the magnetic moment of the electron to 12 decimal places and get the right answer. So even if the one electron story is a myth, it is a myth that points to the truth. It is a scaffold that helped us build the cathedral. And isn't that just wonderful? It shows us that the universe is a dynamic, jiggling, wiggling mess of interactions where the past and the future are tangled together. It shows us that what we call empty space is actually teeming with activity, with particles popping in and out of existence, looping back and forth through time. There is a rhythm to it, a dance. We are just little patterns in that dance. We are temporary arrangements of this cosmic stuff. But the stuff itself, it is eternal. It moves forward. It moves backward. It doesn't care about our clocks. When I look at the universe this way, I don't feel small. I don't feel insignificant just because the numbers are big. I feel connected if every electron in my body is the same as every electron in your body and the same as every electron in the sun. Then we are all woven from the same thread. We are just different knots in the same string. The universe is not a collection of billions of strangers. It is a single performance playing out all at once. So, the next time you feel lonely or you feel like you are just one tiny speck in a vast uncaring cosmos, remember the one electron. Remember that the separation you see is just a trick of the light, a trick of time. In reality, it is all connected. It is all one thing doing an infinite number of things. It is crazy. It is absurd. But as far as we can tell, it is how the game is played. And we didn't write the rules. We are just lucky enough to be here to figure them out. Thank you for listening. If this idea made your brain spin a little bit, that is good. That means you are thinking. Go out there, look at the world, and try to see the threads. And please share this with someone who needs to know that they are part of the big picture, because they really